Hello everybody. So today we're going to start on the last section of the chapter, which is 7.6. So a quick recap of the last few weeks that we've been doing. We've been dealing, of course, with systems of linear equations. So those are graphs of straight lines where we have at least two lines on the same graph. And we've been taking a look at the fact that whatever two lines cross over each other, that forms the solution to that system. So first we solve them graphically. We take a look on a graph, see where they cross over, and then we spent the last few weeks taking a look at two different methods that we can solve them using algebra, either using the substitution method or using the elimination method. But it is possible for there to be no solution to the system that we're looking at with the two lines. And in fact, we've taken a look previously at two lines that would not have a solution. So if two lines don't have a solution, that means they would not cross over each other. So what are the kind of two lines that don't cross over each other? If you remember from before the pandemic, you should remember that we spent some time talking about parallel lines. Okay, so parallel lines do not cross over by definition. Parallel lines don't intersect. Okay, so what we're going to do is I'm going to give you a system here. So we'll do negative 4x plus 2y equals 8. And I'll give you negative 2x plus y equals negative 2. So it's kind of difficult to see or to visualize these lines given in this form. So what we want to do is bring both of these to slope-intercept form, or y equals mx plus b form. And so we're going to isolate both of those for y. So when we do that, for the first one, we're going to get y equals 2x plus 4. And for the second one, we're going to get y equals 2x minus 2. Okay, and what we're going to do now is we're going to graph those two lines. Graph the system. Okay, so we got our graph here. Of course, as always, this is our x-axis, this is our y-axis. All right, so I'll do the first one in red. So it looks like this one has a y-intercept of 4, right? That's our b value right there. So I'll do this one in red. So I'll go up 1, 2, 3, 4. That's my first point, that's my y-intercept. And it has a slope of 2. So it's a rise of 2 and a run of 1. So I'll go up 1, 2, go over 1. That's my second point. So I got 2 points there, which means I can draw my line in. So it's going to look a little something like that. And the second one I will do in blue. So this one has a y-intercept of negative 2. So I'll go down 1, 2. That's my first point there. And this one also has a slope of 2. So I'm going to go up 2 over 1. And there's my second point. So again, just like before, I can come in with my line here. And there we go. That's our second line. So if you remember from when we were taking a look at parallel lines and perpendicular lines, the reason that two lines are parallel is that they have the same slope. Okay? And if we take a look, well, the slope for the red function was 2, and the slope for the second function was 2 as well. So we know these have the same slope. Parallel lines because this means because their slopes are equal. Okay. They also never touch. They never touch, they never intersect, they never share a point. So therefore, the system has no solution. There's no two values for x and y that we can ever find that those two lines are going to share. Okay, so you don't actually have to go through and graph these lines to know that. What we can actually do is we can use substitution and we can use elimination, and something specific will happen when we get this case, and I'll show you what that is. Okay, so let's try solving by substitution. Okay, so again, it's negative 4x plus 2y equals 8. And we have negative 2x plus y equals negative 2. So if I want to use substitution, ideally we want to pick a term that has a coefficient of 1. So in this case, this y right here is going to be a nice starting point for us. So what I'm going to do is I'm going to take the second equation here, and I'm going to get the y by itself. So all I have to do here is I just need to add 2x to both sides to get the y by itself, because we have a negative 2x over here. So that's going to leave me with y equals 2x minus 2. Okay. So here I know what y is equal to. So I'm going to take this and make that substitution into that y right there. Okay, so when I do so, I'll get negative 4x plus 2, and now I have to start my substitution for that y. So from the second equation, we've made this, we've isolated the y here, so we can do this substitution. So this y is now going to be 2x minus 2. Make sure you get those in the brackets. Okay, and then I can just carry down the rest of the equation there. And now I can work through trying to get x by itself, because now there's only one variable in this equation. So of course here I need to begin by distributing my positive 2. So in doing so, I get negative 4x. 2 times 2x is 4x. 2 times negative 2 is negative 4 equals 8. And now we can simplify a little bit here. So I'll move this negative 4 to the other side. So it's a minus 4. So I need to add 4 to both sides. Right? Those cancel. So I get negative 4x plus 4x is equal to 12. And now we would want to collect the like terms of these two x terms. But if you notice, we're going to have a problem, because we have negative 4x plus 4x. So of course that's going to simplify to 0 x's equals 12, and as we know, 0 times anything, even if it's x, even if it's a variable, is just simply going to be 0. So we're left with 0 equals 12. So the whole point of going through the substitution was to find a value for x. And here we are with x canceling out. So x disappears, therefore we can't determine value. We can try elimination, see if we get anything out of that one. So again, negative 4x plus 2y equals 8. And negative 2x plus y equals negative 2. Okay, so the two x coefficients are not equal to each other. The two y coefficients are not equal to each other. So we're going to have to multiply one of these two equations by a constant. So we can try canceling out the x's here. So if we want to try to cancel out the x, we can see that this is a 2 and this is a 4. So if we simply double the 2 here, we'll have two 4s. Then we can either add or subtract the two equations. So I'm just going to take that second equation and multiply it by 2, so we can get a 4 for both of them. Okay. So when I do that, I get 2 times negative 2, so it's going to be a negative 4. 2 times this y is going to give us 2y, and then negative 2 times 2, of course, is negative 4. And then I'll just carry over the first equation, put that on top. Okay. And now the question is, how are we going to cancel out those x's? Do we need to add them or do we need to subtract them? Well, if it's a negative 4x and then another negative 4x, if we were to add them, that would be negative 8x. So if we want those 4x's to cancel, we're going to have to subtract these two equations. Okay, so we get negative 4x minus negative 4x. That gives us 0x. That's what we want. Those x's are going to cancel. Good. But now we run into another problem, because we can see here we got 2y minus 2y. Well, 2y minus 2y, that's 0y. And 8 minus negative 4, of course, is 12. So not only did our x's cancel, which is what we were trying to do, but our y's canceled as well. So again, we have 0 times x, which is 0. 0 times y, which is 0, equals 12. So we have 0 equals 12. So again, we're left with a statement that doesn't have a variable in it. Okay. So we're stuck. No solution. Those two lines are parallel. As we saw here, there's no way for us to get a solution. Okay. I want to do one more example, or I want to explain one more thing. I want you to consider this system. 2x plus y equals negative 1, and 4x plus 2y equals negative 2. And I want you to graph them, or we're going to graph them together. So again, we're going to bring both of these into y equals mx plus b form. So the first one, I just have to subtract 2x from the left side. I'll get y equals negative 2x minus 1. So that graph is going to have an or a y-intercept at negative 1, and it's going to have a slope of negative 2. And if I go through and bring the second equation into y equals mx plus b form, you'll actually find that we get negative 2x as well, minus 1 as well. So the first equation is y equals negative 2x minus 1, and the second equation is y equals 2x minus 1. Those are identical. They're the same line. Okay. So in fact, if we were to come and graph them, obviously we're going to have something on our graph here, right? So if this is my red equation, negative 1 is going to go here, and it's got a slope of negative 2, so I'm going to go down 2 over 1. So those are my 2 points there. It's going to look like that. And then if I have my blue one here, well, it's got a y-intercept of negative 1, and it has a slope of negative 2, so it's down 2 over 1. It's going to be right there. Two of the exact same points, which of course is going to give us two of the exact same lines. Okay, so they're identical. So if they are identical, if they're the exact same line, that means every point on the red line is common with every point on the blue line. Every point along these two lines are shared. Okay. Every point on both lines are shared. And if the points are shared, that is the exact same thing as having 2 points cross over or having 2 points intersect. When you have two lines that intersect, they're sharing that point, and that shared point is what our solution is. But now if every single point is shared, that means that every single point is a solution. Okay, and if both of those lines go left and right forever and up and down forever, what we would say then, there are an infinite amount of points that are shared, so therefore there are infinite solutions. Kind of cool. And just some terminology, we say these lines are coincident lines. Okay. So let's see what happens here now with substitution and elimination. So if we do substitution here, so again, for substitution, we should be looking for a term that doesn't have a coefficient or has a coefficient of 1. In this case, it's this y here, so that'd be a good place to start. So if I isolate for y on that one, I simply get negative 2x minus 1. So I have that substitution there for y. So I'm going to drop it into that y right there to see what we get. Make sure you put your brackets there. So you get negative 2x minus 1. So what we'll do next is use our distributive property here. Make sure we get both of those terms with that 2. So, whoops, it's going to be negative, right? Because 2 times negative 2x is going to be negative 4x minus 2 equals, whoops, not negative 1 there, that should be negative 2, sorry. Negative 2. So again, you'll notice, Actually, what I'll do first, I'll move this 2. So I got to add 2 to both sides. I'll move this first, so those cancel. So I get 4x minus 4x. So negative 2 plus 2 gives me 0. And again, we get 4x minus 4x, which of course is 0x. And 0 times x is just 0. So again, the same thing happens. Our x variable cancels out, or if we substitute it in for x, our y value would cancel out. But the point is, we don't have any leftover variables. They cancel out. We don't get a value for either x or y. But there's a key difference here compared to the last example. So in our first example, where we had parallel lines when there was no solution, we ended up with an untrue statement. And what I mean here is this point, at the very end. We have 0 equals 12. Obviously, 0 is not equal to 12. Those are two very different numbers. And the same thing happened with elimination. We had 0 equals 12 here, another untrue statement. So although the variable canceled out, we were left with a statement that was not true. Compare that with the situation here where we have coincident lines, or two lines that are the same, that have an infinite amount of solutions. We arrived, again, our variables disappeared, but we were left with a true statement, 0 equals 0. And of course, 0 does equal 0. Those numbers are the same. They're equal. So what that means is that's how we can recognize what case we're looking at when we're not given the graph. If we're just given 2 equations, if we try to substitute or eliminate to solve them, if your variables get eliminated and you're left with a non-true statement, you know that those lines are parallel. If you try to substitute or eliminate 2 equations and the variables disappear, but you're left with a true statement, you know that those lines are coincident, which means that they have an infinite amount of solutions. Okay, I'm not going to do it here. If I used elimination for these 2 equations, you would find the same thing would happen. You would be left with 0 equals 0. So again, no value for a variable is calculated, but you are left with a true statement, which means that they are coincident lines and they have an infinite amount of solutions. Okay, so I'm going to stop it there for this week. I have a couple examples left for us to do next week that's going to deal with this as well. But for now, I'll get you to work through a few problems. So the homework for this guy here is going to be on page 448 of your book. And I'm going to get you to work through questions 4, 5, and 7 for this week, okay? So make sure you give those a shot. Let me know if you get stuck. Again, I'm in the school Mondays and Tuesdays, so if you wanted to come in, get some work done, you can always send me an email or let me know through Discord and I can get you on the list so you can come in and get some work done. All right, so for now, stay safe and I'll see you guys next time. Bye.